possible that it won't. Okay, so yeah, we already had some interesting questions that I maybe should have recorded, but I didn't because I was trying to stick to a certain format. But now we're gonna start recording now. So we've had a couple of questions from Matthew, which are in the HackMD. But let's now hear if there's a question from Vincenzo.
Yeah, I have some question, but if Matthew have some question before can go, don't worry.
Okay, thanks, appreciate it. So, like when you're learning Rust, one of the training wheels that I found very helpful was like using unwrap, basically not programming perfectly to start. Is there any sort of equivalence for hacking on Rustc that maybe is not the best practice, but will help you kind of just understand the concepts a bit better so you can go back and take off those training notes?
Sure. I mean, the most obvious one I can think of is like go ahead and freely add debug statements, and if necessary, instances of the debug trait to like anywhere that you want, because you want to understand what's happening inside the code, and likewise, even hard coding details about there's certain things about the compiler that when you run it will be deterministic or semi-deterministic in terms of like, either small changes to the source code or maybe in some cases no changes to the source code, but changes to the compiler, the code you're compiling as the input to the compiler. If you leave that fixed, then chances are things like the specific node IDs that come up are going to stay the same, usually, as long as you're not assuming you're not making changes to the parts of the parser and AST generation that are creating those things. And so you wouldn't typically you wouldn't commit code to the repository that has like hard-coded references to specific node IDs. But while you're developing, that's a kind of example of a training wheel where you can be like, look, I'm just curious about this bit of code. I've used the other tricks I've learned about investigating the intermediate representations to see what the node IDs are for particular parts of the code base. And so now I want to like understand better what's happening when I get to this specific expression, when the compiler is handling this specific expression within an overall function. And you could literally just hard code a reference saying, look, I'm looking at this when I see this node ID, start printing some debug information because I want to better understand this particular one. Or if I see this pattern of data, then I want to. So yeah, basically that it's a general idea that you can use in other places in terms of hard coding stuff. The crucial point though is this only works well when you are relatively certain that the data you're inspecting is going to be deterministically generated. So as an example, one wouldn't usually do this with things like memory addresses. Like you usually want to assume that the concrete memory addresses of like data structures that you're pulling out might change with different invocations. And so it might be a mistake to embed those into any instrumentation you're adding, except one, that's not necessarily true. It's often the case that in fact repeated runs, depending on what system you're on, do have the same like memory allocation behavior, and in fact the memory addresses are relatively stable. And second of all, there's tools that I recommend. One tool that I've tried to make heavy use of is this tool called RR. I don't know if you're on Linux, but I've posted some videos about this tool called RR. It records a trace of a run of a program, and so I've often attempted to use it in concert with Rustc to record a run of Rustc and then replay it, and in a debugger do things like say, okay, when I hit like this particular data, as in like this specific memory address, because the traces are totally deterministic in terms of the events that occur, including what specific memory addresses originate as the program executes. And so if you're in an environment like that, where you've actually done the work to put those things in, then in the context of a debugger like GDB or something, you could put in, again, I don't know how much experience you have using things like GDB. I might be talking, someone who's never done these things, but you can make breakpoints with conditions on them, with conditions like this local variable or this field should be this particular memory address. And then that's when you break at that point. And the point is using that technique with a tool, in concert with a tool like RR, you can, get very specific information about particular points in the source code. The other trick I will show you, which does relate to RR as well. I've done videos about Pernosco. I'm going to go ahead and do this again in terms of like showing off the kind of thing that I think is very interesting for investigating problems. Is I was going to try to do a share of my screen, but there's some reason that it's got these exclamation points. I wonder if I won't be able to do that. Let's find out. Allow Zoom to share your screen. Shoot, I bet I'm gonna have to quit Zoom and restart it if I want to do this. All right, my bad. I don't think I can. Well, wait. Let me see if I can share a browser window instead. If it's not going to let me share a browser window, then I'll just have to say sorry. Oh, I didn't properly get things set up before this session, which was my bad. But let me see. So as an example of something, let me see if I can share this. If I can't share it, then I can at least post a link to the Pernosco session that I'm about to describe in the when I vocalize this. Let me see. So if I share, no, I don't think I can share anything. All right, well, that's my bad. I should have made sure this was working before I started the session. Oh well. So the thing I was going to show you is there's a system called Pernosco, which is tightly coupled with RR. I'm posting a link to it in. So the point I was making a moment ago. This is to deterministically determined data such as node IDs. So the thing I'm showing, I posted a link to this Pernosco thing, and the trick here, the thing I wanted to point out is that it's oftentimes hard when you're looking at a piece of code base like the compiler to have any idea where to get started, to have any clue about where to go to identify making a change, something of interest. As an example, if you want to edit a diagnostic that's being produced, the usual hack is to say, you know what, the text of the diagnostics is an error message. It's probably a hard-coded string somewhere. At least some substring is a hard-coded string somewhere in the compiler. So if you grep for that, it'll jump to the point. You'll identify the parts of the compiler that have that string, and you'll probably narrow down the search space for finding the diagnostic. Okay, so that's an example of a kind of trick to immediately get yourself in the guts of the source code, because the other option is to like start at the main function and try to walk through the control flow from the top. And this is totally unworkable. Like in my experience, it is not helpful to try to step through the behavior of the compiler from the top in a top-down manner, in part because the control flow of the compiler is itself written in a way that's this sort of demand-driven query-based system that is not just going in a stepwise fashion, but rather is like demand-driven, seeking a certain value and asking for it, and then doing this lookup, these various levels of indirection. So it's hard to understand from the control flow, because the control flow is first setting up all these like tables and queries and things which don't make any sense, and then it fires off a query, and it's like it's solving this big logic puzzle under the hood. It's not fun to try to figure that out in my experience. But this idea of saying, well, you know what, I have a certain piece of output I'm looking for, and so I'm going to start from there, that is a generalizable technique in the sense that, like I just said, you can grep for the piece of text you're interested in, and you'll end up in a piece of source code. This Pernosco tool generalizes that idea and makes it on much firmer foundation, because what Pernosco does is it gives you a standard out and standard error in a left-hand column, which again, if I could screen share right now, I would. You can watch me present videos about this where I do demonstrate this being used this way. The point is, what Pernosco does is it's using one of these RR traces I described earlier. If you click at any character inside of the right-hand panel that says writes to standard out and standard error, what Pernosco does is it jumps to the middle of the trace that was captured at the exact point where that text was emitted, which means you now have a stack trace that corresponds. You are now at the point in the control flow that that text was emitted, which means you can look at the stack trace and figure out admittedly, it'll be somewhere probably deep in the stack that you don't want to be in, but you can pop up the stack. You can search the stack trace itself and find the part of the compiler that generated that text. And so this works. This isn't just for diagnostics, it's for any kind of output, including like debug statements. Those debug exclamation point statements that are generated, you can click on them, and then scan through the stack trace, and you can find the exact point where that debug statement occurs in the compiler source tree. So for the example here that I just linked, so the example I linked in the chat, I said there's the very last line of standard out, standard error is this print type size thing. So if I click on that, I end up in the guts of somewhere of the standard library of Rust. I end up in like write format instead of standard IO, like line 716, not the compiler, right? Definitely not what we cared about reading about. But if you scroll up the stack, you can scroll up and you'll see, oh, actually this is inside the compiler somewhere. If you keep going, you'll see in fact that it's inside of a place where it's generating, well, let's see, actually, is this true? Hold on. Yeah, there's print2, print stats. Here we go, print type. Yeah, it's in fact a few frames up. There's this code stats, print type size. And so where we look only a few frames up and we see, oh, it's line 97 of this code stats module. And there you look, you're like, oh yeah, there's a print statement right there. And you can then go and click on things like there's a toolbox in the upper left-hand corner, and as in a little link there where you click on that, and you can bring you can click on toolbox. It's a whole bunch of tools, and one of the tools is a local variables box. So you do that, then you can see the local variables that are in the context of the compiler right here, and do things like click on the values for a local variable, and the lower left-hand corner has the data flow that the compiler used to copy that value from one place to another. And so you can skip backwards in time to other points as the compiler was running that correspond to places that things were moved from one place to another. So for example, if I want to figure out how this got an alignment of 1 byte, I can look at the alignment is a local variable. I can click on the 1 that occurs right there, and I see a backtrace through time in the lower left-hand corner that shows type size info being copied, and value 1 being copied from place to place. And I'm hoping, now I'm just doing this, I've never done this before in this particular piece of code, so I'm hoping this actually works out in terms of telling us something interesting. You can at least backtrace and see that there's a place where eventually it says record type. Like a few steps backwards, there's record type size. And that's a place where it's inserting the type sizes into the hash table itself. And you can keep going backwards through this. And I'm hoping that we'll find something interesting. I'm not sure. There's a place where eventually you get to a place where it's doing a bytes. It's after you do all the record type sizes, eventually you see a place where there's a method called bytes on the struct align in Rustc target ABI align. And now if you click on that first one, that's a call to bytes that returned 1. And we can look at the stack for that call to bytes and work our way upward the stack to see, oh, there's record layout for printing, and place where the layout, and we can work our way up to a layout module, the layout of call, where it recorded the layout of some type for the purpose of printing it later. And thus we're now in, like, I don't know if you're in the same place at all, Matthew, but if you might be, at least I'm sitting here at Rustc utils layout, and you can see how this like immediately dives you into the depths of this thing. It's a lot to digest at once, but it's a hell of an amazing way to like immediately bypass a lot of random searching and see what the actual code is doing and how values are propagating from one place to another. So anyway, I'm a huge fan of Pernosco. I try to use it all the time. It's not perfect. And particularly with Rustc, a reason it's not perfect is because the default build for Rustc has debugging info turned off and optimizations turned on. And it's very expensive to build with optimizations turned off. And it's expensive to build with debugging turned on. And yet the best experience I have with Pernosco tends to be in that expensive mode, which is why I've invested in this beef. That's a reason why I've invested in this beefy machine over here to be able to do these builds. And then the good part is you all get the benefit from it in terms of the things I share here. Everyone gets to see the links I'm giving. But yeah, I'm a huge fan of Pernosco. I tell everyone, go ahead and use it on any piece of code that you're willing to post. The problem with Pernosco is that it's this cloud-based service. You have to be willing to share your traces elsewhere. So it's really great for open source stuff. For closed source stuff, you need to contact the company and work out some deal where they won't have your code just be shared out in the wild. But I'm a huge fan of the company and advertise them as much as I can because I think they're freaking awesome. So that's my chance to advertise Pernosco. I will now put a subsequent link to that. Did you have any other questions, Matt? I know you had to go. All right. Okay, how about you, Vincenzo?
Yeah, I have some question regarding the. I see the video, but I already started a couple of months ago to working around the compiler.
Yeah, I figured it was gonna be old hat for you.
Yeah, and the question is related to something that I'm doing right now, and that is related to how the best way to compile the compiler in a way. Right now, I am working on a refactoring on the ARR. Basically, I am changing some ID inside the ARR, and the problem which
IR? Sorry, the HIR or a different IR? Can you
yeah,
maybe write it in the chat? Okay. Refactoring HIR. Yep.
Yeah, and the problem that I am having that I need to clean up the local building and rebuild the compiler from scratch, because sometimes there is some old piece of code, right, that is built with some other stuff, and yeah, yes. Now I am waiting 30 minutes that is starting to rebuild from zero, and I am curious if there is some way to
some other trick.
Yeah.
So okay, the first question is: Are you already using things like Keep Stage 1?
Oh no, I am running the xpy.build,
and that's all you're doing.
Yeah.
You should watch my video. You should watch my video, because my video talks specifically about how to cut down from the default xpy.build to what you need to do to get it to something reasonable. And part of the story there is this Keep Stage 1 flag to xpy build.
Yeah.
It is huge. You should watch the video. It's not that long, and watch the difference.
No, I watched it. Yeah,
okay. Well, the point is, if you're waiting for half an hour, it's probably because of those standard library rebuilds. Probably it might be, unless you're doing something else to avoid rebuilding the standard library. But I don't think you are. So that's my first piece of advice. Is to do that. And I mean, the problem with doing Keep Stage 1, to be fair, is that since you're doing changes to refactor the here, it's quite possible you're in a situation where the stage 1 you built is incorrect in some way because you need to change the here and it puts a broken stage 1. My strong advice to you is, in fact, start with a clean compiler without your changes. Do a build, then start using Keep Stage 1, because that will avoid it rebuilding the standard library with your changes. It'll just keep the old standard library that was built before, and that way you can focus on building the compiler and applying it to small sample test cases that you're making without worrying about whether your changes are actually going to break the build of the standard library, because you won't be rebuilding it. You'll be reusing the old one that was previously built. So yeah, that's my first sort of big piece of advice is understand why I was doing the video, read the docs about this workflow, because this workflow is pretty well documented. Although I will admit, I found Keep Stage 1 very confusing, to the point where I will really admit I was literally asking Joshua Nelson like a week ago or 2 weeks ago. I said, oh my gosh, I just realized what Keep Stage 1 means. Like, and I've been working on this for years, and I had a total incorrect interpretation of what Keep Stage 1 meant. So I'm not going to claim that documentation is perfect because I had the wrong impression of what it meant, but I'm trying to convey what it does mean and how you can leverage that to make your own workflows faster. So that's the first piece of advice I would give. And that's probably the most important piece of advice I'd give. Are you already using a compiler.toml, a config.toml that has incremental compilation turned on?
Yep. But I think the bug
that might be breaking.
Is a little,
Yeah, you'll need so there's reasons that might get in your way or whatever, and are you turning out of curiosity? Are you turning on debug equals true for your builds?
Yeah.
Okay.
Because
I recommend doing that personally. You need that in terms of helping you, double check your work and whatnot. So I do recommend doing that. If you're not going to use a debugger like LLDB or GDB or Pernosco, if you're not going to use those, then I would probably leave optimizations turned on, because it's better for the process, the speed of the development of the thing, and it's not going to help you to have optimizations turned off usually, unless you're trying to get unless you're trying to make the debug experience more usable in a debugger like GDB or LLDB. Are you using debuggers like that, or are you just working on
no
log output?
I am a fan of reading the stack trace. So
almost everyone on the team does not use debuggers like GDB and LLDB. Almost everyone I talk to is a big fan of spitting out output via debug exclamation point statements. So those are the big things I'd recommend. The other thing I will note in terms of workflows, this is not related to your question directly, because you asked about how to improve the build process. But if you don't know about the flag, you know what? I'm going to write this in the notes for any tricks to get started. This may not matter, but there's a flag called treat error as bug, and an attribute. I don't know if this is going to matter as much either. See error, I think it's called. The point is, treat error as bug. Normally, errors that we encounter are immediately are sort of gathered up, and they aren't fatal errors. They are queued up for being emitted, and then we try to recover and keep compiling in order to find other errors that we can emit as well. Treat error as bug treats the first error that's encountered as a fatal error, which can be useful in terms of if you've got things set up so the first error you encounter is actually the one that is of interest, then it can give you a more useful stack trace. To the point, because if you do the queuing up, then the stack trace you get isn't going to tell you the points where the error was emitted. So that's another. This only helps you when you're trying to understand diagnostics that are being emitted. It won't help you. I don't know if the nature of the kinds of problems you're encountering with refactoring are about ICEs or it's about the compiler just being busted.
ICEs, the compiler starts to build and crash when I will.
All right, and ICE is already a fatal error then. So yeah. Oh, Josh joined and I didn't. Hold on. I meant to say hi to Josh and they left. Which I feel bad about. Oh well. Okay, I don't know if that was Joshua Nelson or somebody else. But I meant to say hi to them, but they didn't. They left now. Oh well, it's okay. Sorry. Do you have another question?
No. This is all the question. I already scanned one time your video, but I think I need to scan more in deep, because
definitely ask. I mean, you should check with us about whether the technique don't just rely on the video itself. Like if there's anything that's a question at all, go ahead and ask in the somewhere in Zulip, probably in T-compiler help, and literally tell us what the command line invocation you're using is as your normal workflow, and people will give you advice about how to revise it to improve the cycle time and whatnot. So they'll either I or someone else can sort of spell out exactly the recipe that I said before and point out where it goes wrong, because these things certainly can lead you astray, especially keep stage 1. There's a very strong warning in the documentation saying that if you use keep stage 1, it can lead to very strange problems in certain scenarios, because if you change the API of the compiler in some way and don't rebuild the standard library, you can get really bad problems, like things where linker errors or worse, where just the code generation can just be wrong, and you don't understand what's happening without using a debugger like GDB or LLDB. So yeah, it's not a panacea. Okay.
Yep. I don't have any other question. Maybe on top of my mind. But
Okay.
Yeah.
Okay. Well, definitely reach out if you think of anything. Okay. Well, my plan then is there's no one else queued up. So I'm thinking that the best thing for me to do probably is to stop the site. I mean, I did promise that I'd be here I said I'd be here starting at 9:30, and the question is whether I should hang out here. What I'm going to do is stop the recording at the very least. So I'll stop the recording here.